Good afternoon. Thank you so much for joining me today. My name is Gay Wilson. I'm the food data curator here at Wolfram Research, and I'm also a registered dietitian. And so I appreciate you joining us today for our computational excellence presentation. What we're going to be doing here today is we're going to be really talking about the versatility of the Wolfram language through food and nutrition analysis. We're going to be transforming some egg recipes with LLM tools. And then also we're going to be the big finish today, and so please stick around for that, is we're going to be using the heat equation to model boiling an egg. And so through a PDE model designed by my fantastic colleague Ricardo, so appreciated, we'll be demonstrating that PDE model. So we don't have a lot of time today, so quickly I want to take a look at some food and nutrition analysis that we've done in the Wolfram language that might give you some ideas of ways you might approach food and nutrition data analysis with our Wolfram knowledge base. You can see that we have we've looked into antioxidants, we've looked into amino acids, osmolality, hydration, which is so important for many of us. You can do statistical analysis with the Wolfram language. You can see linear regression, linear correlation. Also, you can see there's fun things like word cloud. We've done all the vodka flavors of vodka, a word cloud that's in the Wolfram knowledge base. So there's lots of directions to go with food and nutrition analysis in the Wolfram language. So highly recommend take a look at that. In fact, I wanted to share some resources before we get into the LLM tools. I did want to share some resources that you can use for ideas and these tools that we've built for you for your own analysis. If you go to the Wolfram function repository and just put in the word food, you'll see all these really cool tools. We're going to show a few of those today. And then also take a look at the Wolfram language example repository. And there's a food and nutrition category. We're going to look at one of those today as well. And then I also want to put in a little shameless plug for my page in Wolfram Community, Gay Wilson. And I am trying to regularly publish some interesting ideas and thoughts there. So do take a look at that as well. So those are some resources available. Next, I wanted to talk, speaking of the functions, the LLM functions we've designed, we've done several for recipe analysis. So I want to look at a few of those. The first one we did is recipe graph, where we've asked the LLM to return a directed graph of the ingredients and the instructions for a recipe. For example, either you can give it your own recipe, or you can ask the LLM to get your recipe for you. So in this case, we've asked for a vegetable frittata recipe, and then asked us to give, people may prefer flow charts for the way they cook instead of just text recipes. So this is a fun way to do that. Moving on, another LLM function we've designed recently is recipe risk analysis. This uses the LLM and take a recipe and highlight the potential food safety hazards in that recipe. And you can see we just given in this example a basic scrambled egg recipe and asked it to the LLM to highlight those hazards. And as we know, eggs do have risks of salmonella, so we do have to be careful with those. And so the LLM has highlighted the potential contamination from eggs. Now we're going to come back and circle back to the recipe risk analysis in just a minute and spend a little more time, because you may be saying, what are critical control points? Good question. So we're going to circle back to that in just a moment. Before that, I wanted to also show the recipe allergen finder. Now, this is where we've asked the LLM to take a recipe and identify the potential food allergens and potential food intolerances in that recipe. Now, I do want to give a quick caveat about this particular function. If you have severe food allergies or food intolerances, it is still important to do your own homework, not just depend on the LLM to identify that. Keep looking at those ingredient labels like you probably are already doing. Keep looking at those recipes. So do your own research and if you do have those severe food allergies or intolerances. But the LLM is a good way to get started. So you can see in this recipe that we gave it for beef stroganoff that it did identify the gluten intolerance ingredients, the milk allergy, potential allergens for milk, for eggs, for fish, and for sulfites in that particular recipe. As I said, we want to circle. I want to circle back to and look behind the scenes, so to speak, on recipe risk analysis, and look at the function that we wrote for that. In this case, we wrote a persona function, so a persona prompts. So if you're familiar with persona prompts, in this case, we asked the LLM told it that you're the food safety manager at a high-profile restaurant. And your job is to make sure that the restaurant staff are going to follow the US FDA's HACCP guidelines when they are preparing recipes. Now, the US FDA, if you've ever worked in food service in the US, you're probably familiar with hazard analysis and critical control point protocols. And that's to identify and try to prevent and monitor for those steps that may introduce food hazards. And so what we've done is we've told the LLM that you're going to be identifying these critical control points of the new recipes before the staff is trained. A couple of other things, as you can see, it's always good to give an example, to give examples to the function as well, and that's very, very helpful. Next, we're going to look at building a recipe timeline, which this is a lot of fun. Go back, this is in the Wolfram language example repository. So take a look at this. In addition to flowcharts, the timelines are helpful, especially in busy kitchens, whether it's a home kitchen or a commercial kitchen. And this is an LLM function we wrote to output as a timeline plot. So you can see we wrote this LLM function and told it how we wanted to output, how we wanted to retrieve the recipe, how we wanted to output the recipe, what format, and then as we know, giving examples is really, really important in your LLM prompts. And in this case, we told it, give us the instruction, then give us how many minutes for that step. So you can see I asked it to go get the pasta alla carbonara, staying with my egg themes today. So staying with that, and it's gone to get the carbonara recipe. We've done some formatting here as well, doing some color gradients and so forth. And then we're using time object. These are not, because these are not dates, these are time intervals for each step of the recipe. So in that case, we're using that time object. And you can see it's output a really nice timeline to follow for producing your carbonara, cooking your carbonara. Also, I do recommend when you go to the Wolfram Language example repository, pull up, build a recipe timeline, and you'll see we have some other examples in there because you're saying, how often do I cook just one recipe? I'm cooking 2 or 3 at a time. So there's an example of putting 2 recipes in one timeline plot so you can juggle all the tasks needed. So that's your homework, is head to the example repository and see how to do that. Also wanted to staying with our egg theme today. I love formula data. There's lots going on. There's lots of topics, lots of data, formulas to look at. I wanted to look at one in particular, egg boiling time. Here's an example of the variables within that formula. I basically said I've got a 50-gram egg. I want to start at room temperature. How long is it going to take for that egg to boil? And you can see it's going to take about 5.8 minutes for that egg. Also, we have an alternative. We have a boiling that egg at high altitude formula. So I said, hey, pretend I'm in Denver. I'm in Tennessee, but let's say I'm in Denver. I'm boiling an egg at 1,600 meters because we know at higher elevations, the atmospheric pressure is lower. So the water is going to boil at a lower temperature, and therefore your egg is going to take a little longer to boil, to cook fully. So I've said that taking that formula, and then it's basically the formula has told me, oh yeah, you're right, that it's going to take almost 7 minutes to boil that egg, a little bit longer. And then it's also giving me the boiling temperature in Denver for that egg. So you can see that. And you can see that those are lower boiling temperatures. I just want to kind of highlight what's coming in Wolfram Alpha, some cooking formulas that are coming in Wolfram Alpha. I'm very excited about these. They're going to be demonstrating energy use and carbon footprint for different ways of cooking. And such, for example, things, what I'm planning to go back and do, so watch this space, is go back and do with these new formulas is make an analysis of things like cooking in a gas oven versus an electric oven. I'm interested in energy use and carbon footprint of that. Cooking in an aluminum frying an aluminum frying pan versus grandma's cast iron skillet, because as you may know, cast iron cooking is really making a big comeback. So what's that energy use and carbon footprint difference between the cooking in that aluminum pan and that cast iron? Also, this is an interesting one. This was new to me. Is cold storage. Say you have a full refrigerator. Or you try to clear yours out periodically, and so your refrigerator is not as full, or it's just stuffed full. So what's that energy use difference and the carbon footprint difference between those two? So I was surprised by the outcome. So you may be too. So watch for that. That's coming soon. And caloric content by food mass is very helpful. That's taking the grams of the macronutrients, such as protein, fat, and carbs. Say you know your calories, but don't know your grams of the macronutrients, or vice versa. You know your grams of macronutrients, but you don't know your calories. So that's going to be very helpful, that particular formula. This is just a quick look at the boiling in water. Again, staying with my eggs, boiling that 50-gram egg, and how long, what's my energy use, and what's my carbon footprint. So more to come on that very soon. I'm so appreciative to my awesome colleague, Ricardo, who kindly agreed when we asked him to build a PDE model of boiling an egg and that temperature evolution inside the egg as using the heat equation. And so I'm so appreciate this is so cool, this PDE model. Now, as a registered dietitian, I'm just going to be narrating this. So my colleagues are monitoring the chat, the Q&A, and so they'll be collecting the questions for that at the end. We will get back to you with any answers for questions you have about the PDE model. But I'm your host here today. I wanted to show this to you. So as you can see, Ricardo's computing the egg center of the mass used with the shell's coordinates. And then I'm just going to kind of show what's going on here, using the outside of the eggs at boiling temperature of water. Those of you familiar with PDE modeling will be familiar with what's going on here. And then you can see the values depending on the temperature and so forth. And now I do want to mention, as we're going through this, if you go back to the description of this talk in the attendee hub, the Wolfram Tech Conference attendee hub, these slides, there is a link to download this notebook. So I do recommend highly, especially to get this PDE model, do download those slides so you can work with this notebook directly. So I do recommend that. So there is a link available in the attendee hub to these slides. You can see we're continuing. He says he defines a piecewise function for the heat capacity here. And then, so the first condition we're looking at is a room temperature egg. So I've chosen 20 degrees for that room temperature egg. I don't want it too hot. It's sort of the low end of room temperature. And so that's our initial condition for this first model, use of the model. And you can see at the bottom, there's the standard temperatures for at what temperature that the white and the yolk will denature. So then he's created this animation of the temperature evolution of that boiling egg. And so you can see here the denature temperatures for the egg white. That's that green line, that dashed green line, and for the yolk, that's that dashed magenta line. So if we run this animation, right now I have it sitting at where the egg white is mostly the point at which the egg white is mostly denatured. And you can see this is a fantastic animation here. I love it. So do download that notebook so you can do this yourself. So I'm going to pause that real quick and then we'll move down, and he's kindly created this table for us based on that particular model, saying that with a room temperature egg, that white denatured at about 4.8 minutes, the yolk at about 9 minutes, and if you like that runny yolk, 6.6 minutes for that. But what if the egg is taken directly from the refrigerator? Okay, let's look at that. Let's define a new condition, because that's what I do. Especially those of us when we buy commercial eggs at the supermarket. This is my dietitian hat I'm putting on. Leave those eggs in the carton. Don't put them in the door. Take them out and put them in the door like we did in the old days. Leave them in the carton in a cold part of the fridge. Because they do need to stay refrigerated. So we're going to start with that refrigerated egg now. We're looking at the initial temperature of 4 degrees. So we're going to solve that PDE again. We're going to animate, visualize. You can see I've renamed that solution fridge and frames fridge. So we're going to visualize that new solution. And if we run that, frames fridge, and that's the egg came out of the refrigerator, you're going to see it's going to take a little bit longer. And so download that notebook so you can see that, work with that animation. And then again, Ricardo's built this great table for us. Essentially summarized, you can see the time differences on that room temperature egg that the model's given us, the room temperature egg versus straight from the fridge egg, and the cooking differences, the denatured temperatures. So essentially what we come away with is the PDE model shows us that cooking time increases by about 0.6 minutes when the egg is taken straight from the refrigerator. And in essence, however you like to cook your room temperature eggs, that means you add about 40 seconds if that egg is coming out of the fridge. So it's a fantastic model. We got one more step of this model I want to show off. And that's the boiling this egg with that, using that initial solution, that room temperature egg. We're going to use density plot function to visualize a 3D version of the model. So this is the code. Again, download the notebook so you can get this code. And so our first example here is we're showing that internal temperature at 2 minutes, 120 seconds. And the great part about this, with you can, twirl that around, and see different perspectives of that. So that's at 120. But I tell you what, so now we're saying, okay, well, what does my egg look like at 3 minutes? Let's see what happens here. So taking a look at that. So there's my egg. We've got another minute on the cooking temperature there. So let's go. Let's add another minute. Let's see what our 4-minute egg looks like. Let's see how that temperature is evolving inside that egg. Okay. Yep. We're getting cooked there. Definitely getting some cooking going on there. So that's just really cool. I appreciate my colleagues for this fantastic PDE model. You can see the link in the notebook. If you go to see more PDE models there and take a look, there's lots to investigate in the documentation there of PDE modeling. So that very enjoyed that. I wanted to take a couple of minutes here just to look ahead at what we've got going on in food and nutrition. It's never a dull moment in Wolfram Food and Nutrition. So we're working with food and recipe analysis with semantic search and retrieval augmented generation. I know we have some talks on that topic, and I'm going to be attending those talks during this conference. Hope you do too. We do have the first installment of our look at RAG and semantic search with food and recipes on Wolfram Community under my page, Gay Wilson. So please visit that. Hopefully it's the first in a series. What I'm also working on right now is I'm doing some wine food curating data for some wine food pairings. See, never dull. Love my job. And so those wine food pairings, I'm learning a lot about grapes. So we're planning to build a function for the Wolfram function repository. So you'll be able to enjoy getting that. Working with wine food pairings. I'm also working on pulling together saturated and unsaturated fatty acids. As we all know, monounsaturated, polyunsaturated fatty acids, omega 3s, omega 6s. That's a lot. There's a lot going on. So I'm doing some work with the Wolfram knowledge base, and we'll be publishing on those fatty acids. Also, we have so many fantastic groups within the Wolfram scientific content team, and we like to work together on topics. So we are also looking at food chemicals and possibly putting together some, maybe something in the data repository, but some really focusing in on those chemicals in foods. And then lastly, another interesting thing we're looking at is the carbon footprint of foods during production and processing. Now, we looked at the formula data earlier where we got carbon footprint and energy use, right, from the cooking itself. So we're able to look at that. This is going to be the carbon footprint of the foods during their production, during harvesting, growing, production as well, and processing. So because it's a really important topic these days. So we are working on that as well. So I sure appreciate you being here today. Another plug for downloading that notebook. I'm going to take a look over here at the chat and the QA, and also and see what questions we have. And another, please, whatever food and nutrition analysis you're doing with the Wolfram language, please share it with us. I'm always excited to see when people contact me and say, hey, I've been working on this recipe tool or new recipe database. And so we're very, very excited when you publish that on Wolfram Community, share it with us, see how we can help you. Do contact me and say, hey, I need some help with this. So do that as well. Let me look over and see if we've got, oh, thanks for the wonderful comments. I certainly appreciate that. Thank you so much. And so fantastic, fantastic. Again, thank you to my colleague Ricardo for that beautiful, beautiful model, PDE model of the boiling egg. So I'm very, very, very excited about that. So download it and run it on your own desktop. So thank you so much. And if we don't have any other questions, but I love the comments. Thank you so much to everyone. You're so kind. I really, really appreciate it. Thank you so much, and have a great rest of the conference. And I'll see you at some of those in the next couple of days. Thank you so much.